here is law of sines and cosines, sample problem number 3. So this is a different type of problem. Really, I think it would be much easier to solve this because we're given our values here. So when we have 3 different types of measurements given here, it's best to first make a diagram that sort of portrays these values. So we know that measure of angle A is 42 degrees, measure of angle B is 35 degrees, and the length of side C is 1.2. So I would just make a triangle here, and again, it doesn't have to be drawn to scale, and really I would just label this as A, and this is B and C. And so you know that this side length is lowercase a, lowercase b, lowercase c. So this one would be 1.2. This is A, and that's B. And we know what A is. We know the measure of angle A is 42 degrees, right? And we also know that the measure of angle B is 35 degrees. So really what we want to find is, we want to find this, we want to find the measure of angle C, and we want to find the lengths of sides A and B here, right? So to do this, I think the first, again, you want to classify this triangle. So clearly when we look at this, we see that there's a side that's between the two angles. That indicates that this classification is ASA. And as I said before, when you have ASA, you may not even want to use the law of cosines, right? Again, because you have majority of the angles given, and so you can just use law of sines to determine this angle. Not just this angle, obviously, but even you can determine lengths A and B using law of sines because it's ASA. So now we can determine all these measurements, the ones that are not given to us. But first, let's just look at angle C, and we have been given the other two angles, so we just add those two. That gives us 77, and we're subtracting that from 180, and so we know that measure of angle C is 103 degrees. So we can write that measure of angle C is 103 degrees. So that's measure of angle C. Now we need to find A and B. And so really what we're saying is that 1.2 divided by sine of 103 degrees, right? That should equal B divided by sine of 35 degrees, and that should equal to A divided by sine of 42 degrees, right? Because it's just using that law of sines. And so if you think about this, you would just take this there, so it would be 1.2 times sine of 35 degrees, all divided by sine of 103 degrees, should be giving you B. And so you would do that, and once you find B, then you can obviously find A, or you can just do sine 1.2 times sine of 42 degrees divided by sine of 103 degrees. It will give you side length A, and so you can determine the lengths of A and B. And so here you do have an obtuse triangle here, right? But again, this angle is given to us, so we really don't have to worry about finding that specific type of angle because we have been given, or because we already knew this was 42, this was 35, therefore this must be 103. And to find the side lengths, we're just using the law of sine, so we don't have to worry about whether this angle is 80 degrees or 103 degrees, because we don't really care about that, because we have to first meet the property of a triangle whose sum of interior angles is 180 degrees. And as long as we meet that criteria, we don't have to worry about anything else. So we're just using the law of sines here. It's quite simple, and just substituting the values in, we can find the measures, lengths of A and B. And so doing that, you see that side length A is 0.82 units, and then side length B is 0.71 units. And it makes sense because B here is 0.71. That is the smallest side here because it's opposite the smallest angle. A is 0.82. That's a side that's in between, and 42 degrees is a middle angle as well. And obviously your C, 103 degrees, is opposite the longest side of the triangle, which is obviously 1.2 units. So that's sample problem number 3, and so that again just gives you an overview of when to use the law of sines. So thanks for watching.